Okay, so we will start now. In this session, we will solve calculation based on Griffith theory and fatigue crack growth rate will calculate. So this is a GATE previous year's question paper solution, week 1, round 2. So can you tell me what is Griffith crack theory? Anyone? I will cover mainly questions part. Theory I will touch only like formula, what is the formula. Can anyone tell me what is Griffith crack theory? Anyone? You are here all metallurgy student, right? Anyone here whose branch is not metallurgy? Who has some different branch? Am I audible, right? Hello. Surya, am I audible? Okay. Can you tell me what is Griffith crack theory? Anyone? I have already written formula and its criteria also. Like Griffith crack theory, it is applicable for brittle material. If there is no plastic deformation in a material, then we can apply Griffith crack theory, and it is valid for only very sharp crack. So if we want to calculate fracture stress, then from this formula we can calculate fracture stress. This formula is called Griffith crack theory formula. So can anyone tell me what is gamma S here? Yeah, surface energy, specific surface energy. And each modulus of elasticity. And this is fracture stress. And this is our crack length, half crack length you can say. If crack is embedded inside the sample. So can you solve this problem? Here we have two samples A and B, and both are brittle materials and have crack lengths in the ratio of 9:1. The ratio of tensile strengths measured normal to the cracks of A and B will be in the ratio of, like crack lengths are given. It is 9:1. You just put on this formula, you will get. Anyone here? This question is only for the, you can solve in 10 seconds. 1 is 2, 3, right? Anyone else? Anyone is getting some different value? Please write in chat box whatever you are getting. So 1 is to 3 answer will be. See how will we solve. We know it is brittle material, so we'll apply this Griffith criteria. Sigma equal to 2e gamma h divided by pi a. So this is of same material and crack lengths are given. So suppose sigma a, if we assume, then 2e gamma s will be the same, pi into, suppose it is a, and for b we can write same 2e gamma s by pi into ab. So if we assume equation 1, equation 2, and if we divide it, it is asking the ratio of tensile strength measured normal to the cracks of A and B. So it is asking sigma A by sigma B. So if we further calculate, this is A. So square root of crack length AB by A, and it is given 9 is to 1. So we will write 1 is to 9. 1 by 3. So sigma A ratio sigma B will be 1 is to 3. Anyone having any question, any problem in this question? Is it okay for everyone? You may ask if you have any issue. This is the second question. It was asked in GATE 2016. I have given again because here both internal crack and surface cracks are given. So can you try for this question also? A glass has two parallel cracks. Internal crack value is 5 micrometer, and for surface crack it is 3 micrometer. And we have to find out fracture stress in megapascal. It is glass, so it is a brittle material, so we will apply Griffith theory. In formula, which one will set? Like internal crack will assume or surface crack? Can anyone tell me? Here both are given. You are saying surface crack, but why we will use surface crack? I will say why not internal crack? You are right, I will say. Why will we use surface crack? Anyone? As we know, this is for internal crack. It is embedded in the steel or in the matrix. So this is half length, half crack length. If it is on surface, then there will be no constraint, and if it is inside the steel matrix or any any sample, then there will be some constraint from both sides, from all dimension. Therefore we will, if we multiply 2 into this surface crack, then it will be, the value will be like 6 micrometer, which is greater than your internal crack AI value, which is 5 micrometer. That's why we will use this surface crack. On the surface, there will be less constraint. It will be free to uh, free free for crack to propagate. But if it is inside, then there will be some constraint. There will be some other material also. So more stress is required. So what will be the value? Gamma S and elastic modulus is given. Anyone else? Okay. Yalla. Pratik. So we will simply calculate same way. 2 gamma S by pi. So here this is half length. So what will we assume here? 2 into 70 minus 6. 1. Total surface length, it is 3. So after calculation, we will get nearly 120 megawatts. Okay, it is right. Kamesh, nearly 121. Yeah. Anyone having any issue in this question? You may ask. Yes, answer is right. It will be 121 nearly. This is Paris law equation, and here we have to will calculate number of fatigue cycles required to break the plate, and this equation is given Paris law, and where dA by dN is fatigue crack growth rate, and the different values C delta K M, these values are given. So can you try number of fatigue cycles required to break the plate? What will be the total number of fatigue cycle? I think it was asked in GATE to 2018, in between 2018 to 20. Here you just take care of this unit. Question is visible, right? Hello. Okay, so can you try? Every value are given, you just have to put in this equation, Paris law. And here we have to calculate also this thermal stress, like thermal strain are given, like delta T is given. Suppose I have not written this temperature. Temperature variations are from 27 degrees centigrade to 350 degrees centigrade. From this temperature variance, we will calculate thermal strain. What will be the thermal strain? This value is given. So it will be alpha into delta T. 8.4 into 10 is equal to 10 is to power minus 6 into what is the temperature difference? 350 minus 27. And from here we will calculate thermal stress. Can you anyone here calculate what will be the thermal stress value? Elastic modulus are given, E value, and we know of silent strain, thermal strain. Anyone? You may write down in chat box also whatever answer you are getting. Hello. No, no, it is running. You have just come, all right. Here some data are given, and you have to calculate number of fighting cycles required to break the plate. Okay. Yeah, yeah. You are means right now you are in third semester, right? You okay, okay. So I don't think it is required for you, but see everything is given. You have to just put the value. Miss, this is a Paris law. Miss, in Dieter book you will find. Okay, and you just put the value. Everything is given. What will be the thermal stress value? Please calculate and write down here. From Hooke's law, we know sigma equal to E into epsilon. So now can you calculate? Yeah, it will be 314.7 megapascal. it is maximum stress. So we know delta K value, K max minus K mean. Here K mean we will not take because in compressive uh, it it does not help in crack growth. This is only main component. So K max will be sigma max pi a, and from here can you now calculate critical radius? What will be the critical crack growth rate? What is the critical crack length? Sorry, crack length. Critical crack length. What will be the value of SC? Why we are calculating? Here we will integrate from AI to AC. This is internal flaw already present in our sample, and if we find out AC value means critical crack length uh, where fatigue plate will break, then we can find out this cycle NF value. That's why I am calculating AC value, critical crack length. What will be the value of AC? You just put the value, it is everything is given. This K max is K IC sigma max. This value is given. So can you tell me what will be the value of AC? Okay, means what will be the value of AC? Critical crack length. I want you to solve this problem. I have just given the question and I want you to solve. There is one more question based on this, so please calculate fast. In if this question will be asked in gate, you will be having merely 4 to 5 minutes. Now can you tell me what will be the AC value? Yeah, 0.034 meter. Everyone is getting same value. It is 0.01720. Can you check? Yeah. So we have got now AC value, and already we know this equation. You just take care of unit because delta A here is delta A value it is given. it is millimeter per cycle. So if we calculate dA by dm C into delta K M, we have multiplied 10 to the power of minus 3 to make it meter per cycle. So what will be the dn value? Dn value we can write down dA divided by C into delta K power n minus 3. Now we put all value dA. C value is given. What is the C value? 0.69 10 to the power of minus 14 into delta K value is given also 314, and M value it is 4.4 into, we can write pi 2.2 into 10 to the power of minus 3. And what will we do? We will integrate from 0 to NF, and this A will vary from AI to AC. So can you now solve? Can you calculate NF value? You will get all notes. Okay, you try to solve this question. Abhishek, you will get it. Here AI value is given. Initial AI value is, suppose it is given 2 mm, so 1 mm, and we will convert it into SI unit, meter. And AC value already we have calculated from here 0.01720. So now can you calculate? Subham Sharma, is it okay? Here you do not have to do anything, just put the value, integrate it, and just take care of unit. So what will be the NF value? Here I have forgotten A 2.2 also. Minus 14 into 3.314 minus 2.2 plus 1 minus 2.2 plus 1, and it varies from AI to AC. So NF, can you solve now? I have written everything. What will be the final NF value? Hello, this is minus 1.2, minus 1. You please solve problem. Do not ask for notes. In GATE, why are you searching for notes? Questions are given and you just have to solve. 47. Why this value is very less? We have to multiply by this also. Like it was 10 to the power minus 3. It was inside, so it will be plus 3. So NF value will be, if you will solve, you will get minus 1 by 9.9597, 1 by 0.01730. This is power of 1 by 1. 10 minus 3, 1 into 10 to the power this one plus 3. So if you will solve this, you will get nearly. What will be the answer? Can you tell me now? You just solve this one. It is usable, right? It will come nearly 3.86 into 10 to the power of 5 cycles. If you are facing any issue, now you can ask. Hello. So for you it's okay, right? So I'm moving to next question. This is for mild steel plate, and here we have to calculate same thing. Can you solve it? And this is perisla, and here M value is given. In earlier case, it was 4.4, and here it is 3, and C value is given also 6.9 into 10 to the power of minus 12. and already it is given in meter per cycle, so you do not have to multiply by 10 to the power of minus 3. So can you solve this one? Please try this one. You please tell me the process, anyone here? And this alpha is geometric factor, you can say. Are you guys trying or not? Hello. I will wait for 3 to 4 minutes. Okay. Same procedure. You just put the value and just integrate it. Just find out. Here we have to find out NF value, means 0 to NF value. So here our main objective is to find out critical crack length. If we will find out, we can integrate from that AI value to AC value. Here initial crack length is given AI value 0.5 mm. It is easier than the previous question. What will be the value of critical crack length in this case? This is in meter. Have you used this alpha value for mild steel plate, geometry factor, come less, come S spell. Like we know delta K value will be equal to K max alpha sigma max square root of pi. So here from here AC value will be 1 by pi K max by sigma max into alpha whole square. And here we know this value is given sigma max 180 megapascal, and this sigma mean is in compressive stress. It is, we can say, compressive stress minus 40 megapascal. So we will not assume this compressive stress, we will ignore this compressive stress, and if there is any small influence of mean stress, then we will also ignore. So K max will be simply this 180 megapascal. So what will be the value now? AC value. This is given 100, sigma max 180, and just alpha geometry factor, it is 1.12. So AC value will be what? If you will calculate, you will get nearly 0.078 meter, 78 meter mm. So now we have initial crack length, it was 0.5 mm, and we know this equation is given dA by dN 6.9 into 10 to the power of minus 12 into delta K to the power of 3. So dN value we can write down 1 by this term 6.9 into 10 to the power of minus 12 into this value. What is the delta K? Delta K means sigma max into alpha square root of pi AC of Q, and this is D, and we will integrate from 0 to NF. Here we have to find out NF value. Crack length, initial crack length when there was a no cycle, at 0 cycle it was AI, and when there is a NF, then critical crack length is AC. So now can you find out? Sigma max, it is given like 180 megapascal in megapascal, and this AC we know, and this alpha is also, it is 1.1. So can you solve now? 3 by 2, 1.123. This is a minus 3 by 2 dA, AI to A. This value we know already. Just integrate this one. Can you solve this one only? Anyone here who cannot integrate? What will be the integration of this? Anyone? It is minus 3 by 2. So minus 3 by 2 plus 1 divided by minus 3 by 2 plus 1, and it varies from ai to s. You know integration. If t to the power of n dt is given, then we will write t n plus 1 by n plus 1. So same we have applied here. So now can you solve? So 1.1 to the power of 3 into this value will be minus 2, and AC value is given 0.078. It was in mm, so we will write in meter. Minus 1 by 2 minus 5 into 10 to the power of minus 12 minus 1 by 2. So if we solve, we will get minus 1 by 2. Can you solve now? To the 2 into 2.6 into 10 to the power of 5. Yeah, it is true. This is our final answer. It will be nearly 2.6 into 10 to the power of 5 cycles. 2.61. Any problem you are having in this question, you may raise your question. You may ask, unmute yourself and ask, or even you can write down in chat box. For everyone, it is your correct. Please response. Okay, then this is again. Can you solve now? Already. Sorry, sir, I am not able to follow. Okay, you may note down this question. This is a question, and we have to calculate NF value, means number of cycle before failure. All values are given, and in this equation, Paris law, we can, from this equation we can calculate number of cycles. You just joined, or when did you join? Dhanawat, Sai. When did you join? Okay. Okay. So you just put all value, you just follow, there is a one book data you will find based on that book, you just follow. You told na you are just in third semester, right? Okay, I think you will get this equation in your fifth semester, fifth or sixth semester. Can you solve this question? This will be the last question for today's session. And here fracture stress for a brittle material having a crack length of 128 nanometer, each 600 megapascal, and here we have to find out fracture stress. The value of crack length. What will be the value of crack length if fracture stress is 2 gigapascal? Hello. Okay. Do you know this equation? KIC value, fracture toughness of a material sigma by pi S critical crack length. I have given this question because in this problem I have used this equation, and here you will find here. That's why I have given this question. So now you can solve it, right? Everything is given. If crack length is 128 nanometer, then sigma value is 600 megapascal fracture stress. We have to calculate SC value when sigma value will be 2 gigapascal. At 600 megapascal, AC value is this one. So at 2 gigapascal, what will be the AC value? Yeah, it is true. See, fracture toughness KIC value, we know already this equation. So sigma pi AC value will be equal to sigma is given 600 into pi into 128 nanometer. So if we assume this is in megapascal per meter, this is 600, it is in megapascal already, 128 nanometer, so minus 9. And in second case, it is 2 gigapascal. So 2 gigapascal is 10 to the power of 3. We have converted it in megapascal. So this value will be pi into AC value. We have to find out. So and this fracture toughness, it is constant value for a specific material. Therefore, this value will be equal to this value. So if you equalize both equations, you will find 2 into 10 to the power of 3 into pi s. This pi will cancel out, and AC value will be 600 by 2 into 10 to the power of 3 square into 1 by 28 into 10 to the power of minus 9. This will be in meter, so you will get nearly 11 point, not 11 point, you will get nearly. AC value will be nearly 5.76 nanometer, and it is asking crack length, total crack length. Total crack length will be 2 AC, so we'll multiply by 2 also. Therefore, we will get nearly 11.52 nanometer. Okay, then if you have any problem in this question, Paris law and this Griffith criteria, you can ask. And if it is okay for you, then we will meet next session, next Monday. Do you want me any specific topic to cover, like any specific question? Anyone? You may suggest. Okay, then we will meet next Saturday, next Monday. Stress field around dislocation. Okay, stress field around dislocation. Do you want me to cover any specific, like based on this any question? In GATE, you will not find any theory part. Okay, I will try to cover some question based on this. Obviously, like tau and L relation. Okay, then bye bye. Yes, yes, Dhanavad. Do you guys have any question? Kamesh, Amlan, and Subham. Okay, then I am leaving.